Welcome back, everyone. If you're a focused learner trying to wrap your head around how laboratory competence actually works, well, you are in exactly the right place. Today, we're diving straight into the foundational changes, specifically the introduction of the 2017 update to the ISO/IEC 17025 standard. Now, this document, it is literally the global gold standard for testing and calibration labs. And its introduction lays out a massive philosophical shift in how these labs operate. Think about it. When a lab makes an error, the consequences ripple out wildly, right? It affects the safety of the food we eat, the structural integrity of the buildings we live in, and the reliability of critical medical devices. The stakes are just incredibly high, so setting the proper stage through this introduction is absolutely vital.
Okay, so here is our roadmap for this explainer. First, we're decoding ISO 17025. Then, we'll look at the 2017 standard update, followed by embracing risk-based thinking. After that, we'll define the scope and finally cover some essential laboratory terms.
Let's jump right into part 1, decoding ISO 17025 and the goal of standardization.
Picture a modern automotive assembly line for a second. You need rigorous standardization there to guarantee that every single car rolling off that line meets strict safety and performance metrics. I mean, if the robots welding the frame are off by even a millimeter, the entire integrity of the vehicle is compromised. Well, laboratories really aren't any different. The ISO/IEC 17025 standard functions as the ultimate operational blueprint for these labs. It isn't just about having the right test tubes or the flashiest microscopes. It lays out the stringent requirements a laboratory needs to actually prove its competence. And, crucially, it's about generating valid results consistently, day in and day out without fail. Whether a lab is testing municipal drinking water for contaminants or calibrating the sensors on a commercial aircraft, valid results are the absolute benchmark of their existence.
The exact phrasing used in the standards introduction is actually pretty fascinating. It explicitly states that this document was developed with the objective of promoting confidence in the operation of laboratories. That's the ultimate goal right there. Beyond all the technical requirements, the endless spreadsheets, and the paperwork, this standard exists entirely to build absolute trust. Think about it. When a regulatory body approves a critical new medication, or when you buy a toy for a child, you aren't digging through raw laboratory data, are you? No, you're placing your trust in the lab's underlying competence. Stakeholders need to know with absolute certainty that the test or calibration results are accurate and reliable. This standard is literally the foundation of that global trust network.
Moving on to Section 2, the 2017 Standard Update, a real paradigm shift. So looking back at the older 2005 edition of the standard, it relied incredibly heavily on prescriptive requirements. It essentially told labs exactly how to do everything step by step. And sure, while it was well-intentioned, these prescriptive rules often acted like a straitjacket as technology and processes evolved over the years. But then we get to the 2017 edition, which replaced a lot of those strict, outdated rules with performance-based requirements. The standard explicitly notes right in its introduction that there is now much greater flexibility when it comes to processes, procedures, documented information, and organizational responsibilities. So, instead of being handed a rigid, inflexible playbook, laboratories are now given a dynamic framework that focuses entirely on achieving the correct outcomes. This empowers them to innovate and modernize their processes, so long as they can prove the resulting data is utterly reliable.
Which brings us to Section 3, Embracing Risk-Based Thinking, the New Philosophy.
The introduction to the 2017 edition brings in what is arguably the most important change in the entire standard, the requirement for laboratories to plan and implement actions to address both risks and opportunities. But what does that actually look like in reality? Well, the standard explicitly lists 3 massive benefits. First, increasing management system effectiveness. In a real-world lab, this might mean streamlining a workflow because you spotted a bottleneck that risks delaying critical medical test results. Second, achieving improved results. This happens when you seize an opportunity to, say, upgrade training or equipment before your old systems start to drift. And third, preventing negative effects. Now, this is the big one. This means catching a calibration drift on a highly sensitive instrument long before an entire batch of bad data goes out the door and causes a massive product recall.
Think of firefighters for a second. They're highly trained professionals who bravely run into danger when an emergency happens, right? Well, under older, more rigid systems, laboratories often found themselves operating a bit like those firefighters, reacting to problems, critical errors, or intense customer complaints only after they had already occurred. But risk-based thinking, it completely flips this dynamic. It demands that labs shift from being firefighters to being fire inspectors. They've got to proactively identify potential vulnerabilities, assess the probability of failure, and put robust measures in place to prevent those negative effects before a metaphorical fire ever even starts. It is a huge shift from a reactive mindset to a fiercely proactive one.
But, all this newfound flexibility raises a really important question. If the standard is no longer handing laboratories a highly prescriptive, step-by-step checklist of what specific risks to monitor, who is actually responsible for deciding which risks and opportunities need to be addressed on a daily basis?
The answer is the laboratory itself. The standard places the responsibility squarely on their shoulders, not a distant external regulatory body, not some third-party auditor, but the lab. The exact text clearly states, the laboratory is responsible for deciding which risks and opportunities need to be addressed. This is incredibly empowering for them, but make no mistake, it requires a high degree of maturity and self-awareness from laboratory management. Labs can no longer just tick a box to satisfy an auditor and call it a day. They have to genuinely understand their own unique internal vulnerabilities, their specific personnel capabilities, and the exact environmental risks of their specific testing environments. The burden of proof is entirely on them to show they've really thought this through.
Let's move to Section 4, defining the scope. Who actually needs this standard?
So, the standard is universally applicable to all organizations performing laboratory activities, regardless of the number of personnel they have. This is a crucial takeaway from the introduction. This applies just as equally to a massive multinational pharmaceutical testing facility with thousands of employees as it does to a tiny 3-person environmental soil testing lab operating out of a rural county. Basically, if you generate lab results, the rules apply to you. And take a look at who actually relies on this document to confirm a lab's competence. It's a really wide array of stakeholders. We're talking customers, rigorous regulatory authorities, independent accreditation bodies, and organizations using peer assessment schemes. It effectively serves as the universal language of laboratory competence across all these different boundaries.
And finally, Section 5, essential laboratory terms. Let's establish the vocabulary.
To properly implement the standard, the introduction establishes some vital vocabulary, and it starts with a big one, impartiality. The standard defines this simply as the presence of objectivity. It elaborates that this means conflicts of interest simply do not exist or they're resolved in a way that won't adversely influence subsequent activities of the laboratory. Absolute objectivity is the cornerstone of any valid test result. Let's ground this with a quick example. If a lab is under extreme commercial pressure from a major corporate client to pass a failing batch of raw materials, and the lab management actually succumbs to that pressure just to keep the contract, well, the presence of objectivity is totally gone. Those results are worthless, and that foundational trust we talked about earlier is completely shattered. Impartiality isn't just some corporate buzzword. It is a non-negotiable mandate.
Next up is the definition of a complaint. In the context of ISO 17025, a complaint is an expression of dissatisfaction by any person or organization to a laboratory relating to the activities or results of that laboratory, where a response is expected. Notice the very specific conditions here, particularly that last phrase. This isn't just a general grumbling email or some offhand comment. It must specifically relate to the lab's core activities or results, and, here's the key, it carries the formal expectation of a response. Under this standard, a complaint triggers a mandatory formal review process. It requires a documented root cause analysis and actual corrective actions, not just a polite apology. It's a formalized mechanism for continuous improvement.
Which brings us to the end of this explainer. We've seen how the introduction to the 2017 edition of ISO/IEC 17025 meticulously sets the stage by stripping away all that prescriptive red tape. It replaces it with a focus on performance, immense flexibility, and a profound fundamental emphasis on risk-based thinking. It really is a standard designed from the ground up to foster absolute, undeniable confidence through proactive management and strict, unwavering impartiality. So I want to leave you with this question to genuinely chew on, especially if you work in or adjacent to this industry. Based on these foundational principles, is your laboratory truly prepared to proactively demonstrate competence and fully embrace risk? Thanks for hanging out and exploring this with me today, and as always, keep learning.